Good morning or afternoon, depending on where you're joining us from. I'm Dane Christensen, the Digital Marketing Manager at GridGain Systems. I want to thank you all for taking the time to join us today for comparing and benchmarking data grids, Apache Ignite versus Hazelcast, with Dmitry Sitroikin, who's one of the founders at GridGain Systems, as well as a member of the Podling Project Management Committee for the Apache Ignite incubating project. Now, before we get into Dmitry's presentation, I have just a few quick administrative points to make. Dmitry will demonstrate his benchmarking for about 30 to 40 minutes, after which we'll have 15 minutes or so for Q&A. And you'll notice that just above the presentation screen is a questions button. Click there to ask a question at any point during the presentation, and Dmitry will respond to your questions during the Q&A segment. Now, we may not have time to get to all of the questions during this event, but we'll definitely follow up and answer all of the questions afterwards. So please take advantage of this opportunity to ask questions from an expert in the field. Also, if you would be so kind as to rate the webinar and or leave any comments in the questions area toward the end of the hour, that will help us to improve the material for future webinars. So with that, we're ready to turn the floor over to Dmitry Sitroikin. Dmitry?
Yes, thank you, Dane. Again, thanks everyone for coming in to the webinar. We're going to keep it fun today. We're going to be actually comparing data grids. And as far as data grids go, we are going to be comparing, of course, Apache Ignite, because I'm one of the committers to the project. And we're going to be comparing it to another very popular data grid, which called Hazelcast. I'm hoping you've heard about both projects, so we can actually proceed. So what we're going to be talking about is we're going to compare some features. We're going to compare what's supported in one product, what's supported in another product, and then we'll look at benchmarks and in the context of how you should benchmark. We'll look at benchmark gotchas, what you should and shouldn't do when you're doing benchmarks, and we will actually review some benchmarks that we run on Yardstick benchmarking framework, very cool framework. I'll talk about it. And at the end, hopefully I'll have time and we'll launch our own benchmarks using Yardstick on Amazon AWS Cloud. So let's start from actually looking at what both Apache Ignite Data Grid and Hazelcast provide. Again, we're talking about data grid features. Both projects provide other functionality that you can find on their respective websites, but this presentation is about data grids. So first and foremost, both projects are in implementation of JCache JSR 107 standard. It's a standard that is mostly focused on local caching, but which keeps the door open for distributed frameworks to implement the same API. So it has several implementations. Again, Apache Ignite and Hazelcast are both implementing that standard. But JCache mainly focuses on basic cache operations, puts, gets. Essentially, if you're familiar with Java, then most operations on Java util concerns map API will be supported on JCache, as well as some persistence, write through to database, read from database. Those operations are covered by JCache spec. However, most of the data grids will add additional features. For example, ability to perform transactions on caches, ability to query caches, all those ability to do rebalancing in distributed systems, partitioning, replication, various querying capabilities, maybe messaging events, continuous queries. All those additional functionality is usually added by either vendors or open source projects like Apache Ignite, for example. So again, there are lots of similarities. We listed all the features. So how do we find out what's different? I mean, the projects do look very similar from the outside. So again, of course, the devil is in the details. And we're going to cover some of these details right now. So first and foremost, let's look at replication and partitioning strategies. As I mentioned, both projects support JSR 107. And the main point, as I mentioned again, JSR 107 is about local caching, but both Hazelcast and Apache Ignite are distributed data grid systems. So the main functionality as far as distributed caching goes, the main functionality provided is data partitioning within the cluster. Essentially, every node, because there is a concept of node of data ownership that gets introduced, and every node owns a piece of data. Essentially, if you have, for example, if each node, for example, has 100 gigabyte of RAM, and you have 10 nodes in the cluster, collectively you can cache 1 terabyte of data within these 10 nodes. So every node will cache a portion of the data, and the more nodes you add, the more data you can cache. So most of the data grids support this partitioning schema, and in a strong consistency, and they support it in a strong consistency fashion. So unlike some eventually consistent systems, data in the data grid is strongly consistent. You can transact on that data. You can usually you can even move money on top of a data grid within data grid transactions, and the data should remain consistent regardless of the failure. So for partition caches, both Ignite and Hazelcast support strong consistency. However, there's also a concept called replicated caches, or in Hazelcast they're called replicated maps, where data is actually not partitioned but replicated across all the nodes. So if we take our example where we have 10 cluster nodes and each node having 100 gigabyte of RAM, in partition case we could cache a terabyte of data, but in a replicated case we are able to cache as much as one node can cache. So we would be able to cache 100 gigabyte of data. And replicated cache, so essentially every node will hold exactly the same copy of the data. And replicated caches are useful when you want to store some reference data, lookup data, data that doesn't change too often, but data that you read a lot. And a lot of times you will want to query between partition and replicated caches. Often you will have some combination of the two, maybe 5 partitions, maybe 3 replicated coexisting together in same JVM. But the difference between Ignite and Hazelcast is again that replicated caches are not supported very well within Hazelcast. They have weak, what they call weak consistency. So essentially, after I reviewed the documentation, essentially it meant that if any crash during a cache operation happens, if any node failure happens, data will remain in inconsistent state. So the consistency will not be restored. So it's not even eventually consistency, it's almost inconsistent if any crashes occur. So it's called weak consistency within Hazelcast. In Ignite, again, the same contract as with partition cache, data will always remain strong consistency regardless of any crashes anywhere within the cluster. So that's probably one major difference between two projects. Another feature I want to talk about is off-heap memory storage. If we have any Java developers listening, or Java programmers, or people who actually ever had to configure and tune a Java program, then those folks would be familiar with garbage collection in Java and how hard it is to tune garbage collection in Java. For example, if you have anywhere between 16 gigabyte of RAM and above, you have to start tuning garbage collection. And after spending long cycles on tuning, you eventually come to a realization that you're not really removing this long GC pause. You're actually most likely delaying it towards some later point of time, but it will eventually happen. So just as a point of reference, on a cluster of 10 nodes, if you have a 50 gigabyte of RAM on each node allocated to JVM heap, then it's very common to have a GC pause at some point that can last as long as 5 minutes. And during these 5 minutes, your cluster cannot do anything. It looks frozen from the outside. It's completely unresponsive. And all it's doing is having the JVM, all the JVMs clean the garbage, going through garbage collection cycle. Obviously, very bad for SLAs. If you actually tell your customers every now and then, we're going to freeze for 5 minutes and stop serving requests, it's probably not going to fly very well. So to mitigate this problem, some data grid products, not all, but some, Ignite and both Ignite and Hazelcast actually do provide off-heap memory support. So off-heap memory actually allows you to store very little memory on heap, and then store lots and allocate lots of memory off-heap. So essentially, all the off-heap memory that you use is still a pointer access away. It's still in memory. It's still very fast, but now JVM doesn't know about it. And the difference between Apache Ignite and Hazelcast that is worth mentioning that off-heap memory is an enterprise feature within Hazelcast. So it's available in Enterprise Edition, not in the open source edition. And in Apache Ignite, it's part of the Apache Ignite project, and it's free for all, part of open source edition. Another point I want to mention about Off-Heap is indexing. Whenever working with large amounts of data, indexes may occupy anywhere between 20 and 50% actually of your data, depending on how aggressively you index, how aggressively you want to tune the performance of your queries. So even if your indexes occupy about 30% of the data, and you allocate about 100 gigabytes of storage off-heap, you may end up actually having storing 30 gigabytes of indexes. And it's very important that indexes are also stored off-heap, because if they're stored on heap, you again face the same garbage collection issue as you faced with storing cache values. So in Apache Ignite, if you turn on off-heap, indexes, both cache values and cache indexes will be stored off-heap. So the main heap utilization will remain the same, and JVM will never enter a long GC cycle. In Hazelcast, indexes are stored on heap. So you essentially are limited by the amount of heap size you want to allocate to JVM, and again, take a risk of garbage collection pause when allocating space for Hazelcast indexes. And one of the last main differences, there are quite a few more, but I'm just focusing on the main ones. One of the last differences I want to talk about is different cache querying capabilities. It is very important when actually working in distributed systems. Ability to look inside the data is very important. You generally do not want to start writing extra code to actually be able to or implement any kind of your own indexing in order to be able to query the cache. So the indexing and queries is very important part of data grid functionality. And there are several ways you can access data in a data grid. I mean, we already covered key-based access, which essentially is primary key lookup, but there are no indexes that get utilized. You just executing a direct lookup into a distributed hash map. What queries allow you to do is allow you to access data based on secondary indexes, based on secondary fields. So you actually are now able to index not only by key, but also by fields inside of your Java class. And for example, you can execute query like select star from person where salary is less than 100,000. And you can index a field salary, and the query will execute very fast. So ability to index data is very important. Hazelcast provides a very rich criteria queries API, which is index-based, and somewhat poor, in my view, SQL queries API. They only support 4 keywords in SQL and in, like, and between. This is definitely not enough to support a full SQL capability, and they do not support joins. In either approach, they do not support joins between caches. So in Ignite, most focus was actually put into providing very rich SQL capabilities. There's absolutely no limitation as far as what SQL you can execute on top of Ignite. Ignite is SQL 99 compliant. So you can do inner joins, outer joins. You can do inner selects, unions, group bys, havings, all sorts of aggregates, all sorts of aggregate functions. I think folks executing query SQL statements as large as 4 pages long on top of Ignite in distributed fashion, and the query ran just fine and actually provided results very fast. So there's virtually no limitation as far as what kind of SQL you can execute on top of Ignite, which becomes very important for integration with analytical and reporting systems, or any kind of ad hoc querying. When any kind of ad hoc querying capability is important, it's very beneficial to actually be able to just log in and start writing your own SQL statements on the fly. For example, if you look at the screen, the SQL statement here select several averages from person, joint with department, joint with organization, group based on certain foreign keys, group by organization name, order by average age. So we're looking up different ages of people within organizations, and we're grouping them by organization. And we're joining on 3 tables. It's a very simple, very common query that you can execute on top of Ignite. Ignite can process many queries like this concurrently. You can get performance as high as probably between 10 and 50,000 queries per second, depending on query complexity. So the difference is Hazelcast probably would implement this using criteria query, but not SQL query. And even with that, joins would be very difficult to implement on top of Hazelcast, so you would have to resort to adding some Java code in between. And lastly, I just want to, before I actually start talking about actual benchmarks of the data grid, I want to mention that we're only talking about data grid here. For example, Apache Ignite is an in-memory data fabric. It's not just a data grid. Data grid is just one component we provide, and it's a top left corner on this jigsaw puzzle. But there is also compute grid, service grid, streaming. There's distributed file system, the in-memory map reduce, et cetera, et cetera. So lots of features available. In addition to data grid, I'm not going to talk about them right now, but please go ahead and visit Apache Ignite website to learn more about them. And let's now actually switch to benchmarking. Benchmarking is always a very interesting topic. It gets people involved, emotional, especially when people start analyzing benchmarks. The fairness is always questioned, et cetera, et cetera. So one of the things when we're doing benchmarks, one of the things we're trying to focus on with the benchmarks is transparency. All the benchmarks we run are absolutely transparent. You can actually, not that you can actually look at the code, you can execute these benchmarks one-to-one in the same fashion we execute them. You can look at the configuration and ask the Yardstick maintainers to change the configuration, and they will be happy to change it, given that you probably would know how to tune your product the best. And both Hazelcast and Apache Ignite teams were given an opportunity to look at the benchmarks and to provide feedback. So let's actually take a look at some benchmarking gotchas. Whenever you start benchmarking, first of all, it's very important that you configure and tune your product for the benchmark you're about to run. If you look at distributed data grids, for example, the first thing that you would actually check is number of primary copies and number of backup copies. You want to have equal number of backup copies if you're comparing 2 different products, for example. There are also a lot of other networking properties that you may decide to tune, but a lot of times most of them are good enough by default. All you have to make sure that a benchmark from a behavioral standpoint matches your requirements. I'm seeing a lot of times people just start executing benchmarks and start timing it from the get-go. That's generally not the right approach. JVM has a hotspot compiler. Hotspot compiler analyzes the execution of your program and will precompile the pieces that get executed the most. So you want to let your benchmark run for some warm-up period of time, maybe 30 seconds to a minute. And then after you actually allowed your benchmark to warm up, then you start timing the operations, looking at latencies, network utilization, etc. Benchmarks should be multi-threaded. You're testing a data grid or any kind of distributed system. It will be accessed in multi-threaded fashion. Do not write benchmarks that execute the same operation in one thread, one after another. You are not stress testing the system. You are essentially executing that system can execute operations consecutively and not concurrently. Generally, benchmarks should be multi-threaded. Lots of threads should be bombarding the system at the same time, and lots of threads should be loading it and forcing it to make decisions concurrently and perhaps work in high contention modes. So single-threaded benchmarks are not enough. Execute multi-threaded benchmarks. And what do you measure when you execute benchmarks? Well, I mean, most important characteristics are latencies and throughput. The smaller the latencies, the better you are. The larger the throughput, the better you are. But latencies and throughput is generally not enough. You want to look at more stuff. For example, network utilization. How much network does my benchmark consume? Is this amount acceptable for me? Is it over-consuming with something that I would otherwise be expecting? And lastly, I'll mention that it's not enough to just, a lot of times I'm seeing people writing their benchmarks and simply calculating the time difference between start and end, and then counting operations that happen during that time. So at the end you get total operations and total time, you divide one by another, and you get operations per second, for example. That's not a good benchmark. That's not a good way to monitor benchmark. The reason is you lost everything that happened in between. Your benchmark in between could actually have spikes. It could have drops to zero performance. It could behave sporadically. It could have a lot of jitter. And all of that is not seen when you just measure final numbers. So you actually should do what I call continuous monitoring. You should be continuously monitoring what your benchmark does. So all of this actually looks a little complex. That's why you often do not want to write your own benchmark. You want to write your own benchmarks, but you do not want to create the framework for testing by yourself. There are various benchmarking frameworks available. A lot of them are open source. So today we'll be looking at Yardstick framework. This is my favorite framework. Essentially, it's essentially useful. It's very useful for benchmarking products like DataGrid because it allows to launch a cluster, easily launch a cluster around a series of benchmarks without restarting it, and then providing results at the end. And not only it provides results, it actually generates graphs. And graphs allow you to actually look inside the benchmark at any point of time within the benchmark and see if the behavior was acceptable for your application. For example, Yardstick already has some pre-cooked benchmarks. There are benchmarks for Apache Ignite. There are some benchmarks for Hazelcast there. There will be benchmarks for Apache Spark and Apache Cassandra added. And if you want to add more benchmarks to Yardstick, just notify the Yardstick contributors, and they will gladly add the benchmarks for you. And one of the easiest way to utilize the framework that we found the easiest is using Yardstick Docker extension, Docker containers. The way they work is they receive a URL to a GitHub repository on startup, and Yardstick will automatically download this GitHub repository, build it using Maven, and run all the benchmarks available in that repository. This way you do not have to recreate your own recreate the server configurations every time you want to change a benchmark. All you do is change your code in your GitHub repo, provide the link to Yardstick, and it will run the new code that you provided. And it also comes with AWS public images. And hopefully we'll have time and run I'll demonstrate how to start a benchmark using Yardstick on AWS. We probably won't see it finished, but I will show some results from my previous runs. So let's take a look at some of the benchmarks we've executed. The first one, we will try to benchmark basic JCache operations on top of Yardstick. Here's the code on the bottom left corner of this slide. Essentially, you're doing a get from cache, you're doing a put into cache. It's non-transactional. Stuff could happen in between get and put. We're doing it just for benchmarking purposes. So this code will be executed under load on top of Yardstick, and we'll count how many times it can execute and all the latencies that it took to execute this total piece of code. Not just every single operation, the total piece of code that you're looking at right now. And after running it on Yardstick, you would see on the right side the graphs that are generated. And both Ignite and Hazelcast in the JCache mode provide about the same performance. The difference is insignificant. Ignite is about 4, 5, 7% faster. It's probably not worth making a decision based on this performance difference. So both products exhibit pretty good performance for basic cache operations. When it comes to transactions, the picture is a little different. So when you're working with transactions, you generally have several transactional modes available to you. There are optimistic transactions, there are pessimistic transactions. Ignite has direct support for optimistic, pessimistic. Hazelcast, although it doesn't have the behaviors defined, you can have it coded in a way that it would be similar to optimistic and pessimistic transactions. So when you execute transactions on top of Hazelcast, and on top of Ignite, the picture actually changes. And in both pessimistic and optimistic mode, the picture was about the same. Ignite came around anywhere between 40 and 50% faster than Hazelcast. Here's the code that was running, that we executed. Essentially, transaction start, then you do get, then you do update or put, and then you commit the transaction. If it fails, then you roll back the transaction. So this piece of code now executes as one unit. It has full asset properties, and it will actually complete as a whole or fail as a whole. And this is the performance we've got for that. So about 16.5 transactions per second on Ignite, and about 11,000 transactions per second on Hazelcast. So yeah, as you see, the performance in transactional mode is significantly less than performance in non-transactional mode. But again, it's still pretty fast. It's still very fast in comparison to disk-based transactions, to Oracle-based transactions, for example, or to MySQL-based transactions. So it still provides an order of magnitude benefit when you execute transactions in memory. And last test that we did, and we'll be doing more tests, and I'll be blogging about them as well. For example, querying tests, comparing query performance, etc. But last test that I have available as of today is a crash test on Amazon EC2 cluster. So we started up 4 nodes, 4 cluster members on Amazon EC2 cluster, and in the middle of the benchmark, we executed a put get benchmark, the same code as we looked at before. And in the middle of the benchmark, we terminated an Amazon instance. And this is exactly why I keep saying that continuous monitoring is important. You never want to look just at the final throughput number. You want to see how benchmark behaves itself throughout the execution of the test. So as you see, Ignite recovers a lot better than Hazelcast. For example, Ignite had a quick drop, but it quickly recovered from it and continued to operate. So they from 80,000 to about 40,000 or 30,000, and then it quickly came back up. Hazelcast actually dropped to 0 and stayed at 0 for a little bit before coming back up. So Ignite actually showed that it could recover a lot faster in case of under load on a distributed system than Hazelcast. So all these benchmarks, again, available on Yardstick. You can go ahead and run them yourself. It's fully transparent. You can change benchmark, or if you notice any kind of configuration you want to tweak to make it better or more fair, please notify the Yardstick maintainers, and they will absolutely change it. I know it because we've done the same. And now I want to actually, it looks like I do have time, so I'm going to actually spend maybe about 5 to 7 minutes starting a benchmark on Amazon EC2 and demonstrating how you can easily run your own benchmarks on Amazon EC2 cluster. So I'm going to go ahead and exit from my presentation, and I'm going to sign in into the AWS console. And I'm going to go into EC2 service, click on launch instance. We're starting from scratch. And as I mentioned, Yardstick framework comes with its own public images. So how do we find them? Click on community AMIs on the left and tap the word Yardstick here. And immediately you see there are 2 Yardstick images. One is benchmark server and benchmark client. The beauty here that you do not have to change them because they receive a GitHub repository on startup. So they will run whatever you provide them with. So let's just as an example, go ahead and start Yardstick benchmark server. So let's select this AMI. I like to pick C42X large instance because generally when running benchmarks, as I mentioned, network utilization becomes important, and you want to make sure that on your cloud, you have at least 10, you have a good network connectivity. In private environments, we recommend at least 10 gigabit network. On cloud, you have to have one of the best network configurations that a cloud can provide. So C4 2x instance on Amazon is actually good enough. So let's go ahead and start servers. I'm going to change this number to 4. So we're going to have 4 servers, and I'm going to configure advanced details. And here I will choose the configuration for Yardstick server to run. And I'm going to choose Yardstick Ignite AWS TXT. And just so you know what's inside of that file, this is how it looks from inside. I had to obfuscate access key and secret key values. So they're not correct. Don't try to hack into this account. You will not succeed. This is a Git repo. So 4 parameters we pass in. One is a Git repository. This is, as you see, it's Yardstick Benchmarks, Yardstick Ignite. This is the URL on GitHub. So this is the code that contains the benchmarks. It's a Maven-based project. Yardstick will download this GitHub repository. It has to be public or accessible. Yardstick will download it, build it using Maven, and execute them on the cluster. Then we pass access key and secret key from Amazon, and at the end, Yardstick generates result, and it puts them directly into ES3 bucket, so we can specify the ES3 bucket name here. So this is essentially the file I just provided here, except that in the file I provided, we had the real Amazon credentials, not the obfuscated one I just showed you. Let's go ahead and click next. We don't need any storage. Both Apache Ignite is an in-memory data grid, just like Hazelcast. But so we don't really care about hard disk for this benchmark. Tagging instance, I always advise to tag an instance. You want to distinguish servers versus clients, and if you benchmark in different products, you want to distinguish them as well. So let's tag them as Ignite server. Next, we configure security group. I'm going to select one of the pre-configured groups, which permits, which has no restrictions. If you want to have restrictions, then Yardstick framework actually documents what needs to be allowed within security group for a benchmark to run. So you need to go to Yardstick GitHub page, and it is documented there. Here we just have a default security group that allows everything. And now we can review and launch. We have tags, Ignite server, instance details. We have 4 instances. The instances are selected correctly, so let's go ahead and launch. Choose existing key pair. We already have pre-generated key pair. And to view instances, so instances are starting, and they're going to be waiting for the benchmarks to execute. To execute an actual benchmark, we would have to go through the same process and now start Yardstick client. So if you remember, we in community AMIs, we did a search for the word Yardstick, and we came up with 2 images. There's Yardstick server and Yardstick client. So after you start the servers, then you go ahead and start the client, and you can run the benchmark. There's no difference in the way you would start client from the way you start server. It's the same. You go through the same operation. So after the benchmark executes, unfortunately, I'm not going to have time to run the benchmarks. They take probably about 10 to 20 minutes to run. You can, as I mentioned, Yardstick stores the result on Amazon S3 storage, and we can go ahead into our S3 storage and look. And if you remember, we configured the bucket to be Yardstick demo. So this is our bucket main. We run Hazelcast benchmarks, we run Ignite benchmarks. Whenever Yardstick notices that you have 2 benchmark results in the same S3 bucket, it will generate, on top of individual graphs, it will also generate a comparison graph, which is very convenient because now you can look at comparison graph. And you don't even have to download it, you can look at it directly in S3 view on Amazon. So for example, I'm going to take Ignite TX to get 1 backup. I'm going to click here. I'm going to click open. And notice when I click, when I just open this open this HTML page in Chrome browser, it actually looks a little weird. You have the same graph showing up 2 times. All you need to do is click in the top navigation bar and allow to load unsafe scripts. Unfortunately, you have to go through this. And now the view is actually fixed and the page looks okay. Here's all the information you can grab from Yardstick. We can grab iterations per second, very consistent with what I have shown you. It's actually a little faster. Probably this benchmark was run probably on more servers, and it shows actually 30,000 iterations per second versus 22 on Hazelcast. So again, iterations per second latency, and the whole gstab command on Linux is also benchmarked and shown here as well. You see CPU utilization throughout benchmark, you see system utilization, you see wait time, idle time. Again, for both projects, green is Ignite, blue is Hazelcast. You see disk reads, software interrupt, network send, network receive. Receive is about the same, but Hazelcast seems to be sending a lot more data than Ignite, for example. So all of this is important when benchmarking. And all these graphs are available to you when you use Yardstick. And all you have to do is just download the benchmarks. Just go ahead and provide the GitHub repository to your own benchmarks, or use the ones available at Yardstick and launch them on your own EC2 cluster, and you will be able to see similar results or similar graphs to what I'm showing right now. So this concludes my part of the presentation, so we can actually move to questions.
Great, Dmitry. That was fantastic information there. And we do have quite a few questions here. So let's go ahead and dive in. Here's one. I wanted to use Apache Ignite in Node.js application. Does Apache Ignite have Node.js module, or are there any plans for the same?
Good question. Right now, we recommend that Node.js user use our Memcache compliant protocol. Apache Ignite is Memcache compliant, so you can access it through any of the Memcache clients. And Memcache is implemented pretty much in every language. A client for Memcache is implemented in every language. So you can use Memcache from, you can use Node.js with Memcache API and have an Apache Ignite on the server. Granted, you are not going to have transactions. You're not going to have near caching, client-side caching, or maybe not going to have some compute capabilities that Apache Ignite provides, service grid, etc., streaming, etc. We are currently working on it, and actually very actively. I'm expecting more feature-rich Node.js client coming out probably in about a month, maybe 2 months. There are a couple of contributors to Apache Ignite that are currently working on it. We have a very active community, and we're working on a bunch of integrations. Node.js is one of them. We're also doing integration with Mesos. We're doing a very cool integration with Spark. So stay tuned for more integration coming in within Apache Ignite. So Node.js is definitely coming up.
Okay, great. Here's another one. Wanted to use Apache Ignite as a CEP. Do you have a comparison of Apache Ignite with Esper CEP? Any examples of how we can use Apache Ignite as CEP would be useful.
All right, so the question is how Ignite streaming, essentially, or CEP compares to Esper streaming CEP. Whenever talking about streaming or CEP, there are 2 use cases that become important. One is how you workflow your events through the stream, how your stream actually workflows through the system. And the second is how do you query against that data, how you get event notifications on that data and continuous event notifications. So from that standpoint, both Apache Ignite and Esper probably would provide functionality of ability to set sliding windows into the data and querying into those sliding windows and get continuous querying notifications. I do not have benchmarks of Apache Ignite streaming versus Esper streaming, but it would be something cool that we could probably provide on top of Yardstick. The difference, I would say, is that since Ignite is streaming data into Ignite caches, all the data grid features that I was talking about in the context of a data grid are also available within Apache Ignite stream caches. So even though they work in a streaming fashion, you still can do SQL queries with full SQL 99 compliance. You still can do write-through and read-through to database. You still can transact. You can even query across streams. So from that standpoint, I think you'll get more functionality from Ignite caches because on top of streaming, you also get standard data grid features there as well. And by the way, as far as where you can get started on it, the question was how I can get started. Ignite comes with a set of examples. You just download Ignite, and it has example folder there. And take a look at the word count example. I think it will be something you're looking for. Very cool, very concise example. Shows some complicated query framing on a continuous stream of data coming in into Ignite.
Okay, great. Here's another question for you. Hazelcast has good REST HTTP support. Does Apache Ignite also have similar support available?
The answer is yes. REST API, REST HTTP support is well documented on Apache Ignite website. Just look for REST API header, and it's there. So all the commands within Ignite, a lot of commands on top of Memcache API is provided. For example, you can start remote computations on the data grid using REST API, something that Memcache would not have. You can work with different named caches. You can work with partition and replicated caches. You can do SQL. So there's a lot of additional functionality that you can do. You can get using REST APIs on top of standard Memcache APIs that you can utilize.
Okay, good. Here's another one. Do you have any comparison of Apache Ignite streaming with Apache Spark streaming?
There's actually a project in Yardstick working on that comparison. Before we even get into comparison mode, I mean, it's important to understand the difference in the way streaming works in Ignite and Spark. Spark has a so-called concept called discretized streaming. Essentially what it does, it sets windows or batches in which it receives the data. Usually it's a small batch, maybe 1 second, 2 seconds, 3 second batches. And then once this time passes, then you take whatever comes out of that sliding window and start working on it. So you are not working on the sliding window itself. You're working on the stuff that comes out of it, that expires out of sliding window. Ignite actually works a little different. It allows you Ignite streaming. It allows you to work with the actual window. So not the stuff that's coming out of the window, but you can query and process and compute on the data that is currently in the window, in the sliding window. For example, you can, and that allows Ignite to actually set a much larger sliding windows than Spark. You can set, for example, a window that is 1 hour long, or 1 week long, or maybe 1 day long, which will help you answer what is my average price, for example, for IBM stack throughout the last for the last business day. And a sliding window like that will actually help you answer a question like that. So you can actually define much larger sliding windows, and you query into the windows, not into the stuff that's coming out. If you're interested about the stuff that is coming out from the sliding window, you listen to evicted events that you can attach to sliding window, and then you'll be actually getting notifications about everything that gets evicted outside the window as well. So in that context, we are going to be providing some benchmarks of Ignite streaming versus Spark streaming, but I think it's augmented. They augment each other in the sense that if you need the behavior that Spark provides, use Spark streaming. If you need the behavior that Ignite provides, use Ignite streaming. We are also in Ignite working very actively right now on integration with Spark. Spark has one of the deficiencies, as we see many people complaining. There's no capability in Spark to store persist state between the jobs in Spark. So if you actually cache some data within Spark job, whenever Spark job completes, you lose that data unless you persist it to disk or to a file system. But then again you actually employing an external storage. If you have, for instance, Ignite running within Spark or next to Spark, you could easily persist data in memory. So we're coming out with an Ignite RDD abstraction that you'll be able to utilize to run SQL on top of Ignite and to persist state between Spark jobs. So stay tuned. It's coming out in a couple of weeks, probably in a 2-3 week period.
Okay, great. And another one. Any comparison with VoltDB?
Actually, that would make a pretty good comparison, comparing Apache Ignite SQL to VoltDB SQL. At this point, no, we did not create a benchmark. I'll put it on the list, and I'll ask someone on the Yardstick team if anybody is interested in creating such a benchmark. It would be a cool one to compare. The difference with VoltDB is a database, in-memory database, so it provides you SQL-only access. Ignite actually provides 3 different ways you can interact with your data. One is using key value API, another is using SQL, and the third way is using MapReduce or fork join type of computations on top of that data. So the products are different, so the only thing you can really compare is SQL capabilities, and that would be an interesting benchmark.
Okay, great. And by the way, thanks everyone for all these fantastic questions. There's a lot of questions coming in, and so we'll knock out as many of them as we can here. Here's another one, Dimitri. Have you run any benchmarks that include cross-partition transactions? Even if other vendors don't support it, it would be an interesting data point.
Yes, we have, and the same the benchmark actually that I showed in my presentation, I think this one. Yeah, this is a cross-partition transaction because there is no collocation logic between the key that you're in. No, this is not a cross-partition, I apologize. It uses the same key for get and put. But yeah, we definitely have run them. There's another benchmark that uses different key for get and put, so there's no guarantee it would end up on the same partition. And those transactions work just fine within Ignite as well.
Okay, good.
To answer the question, the benchmark is, I believe, is currently available on Yardstick, so you can take a look at it.
Okay. Now here's one of the tough questions, maybe kind of a gotcha question, and so here it is. Why using an old version of Hazelcast for comparison?
Hazelcast just released a new version. I mean, it's like literally a few days ago. And we will, I think, I mean, the Yardstick guys will rerun the benchmarks, but the results were not much different from initial comparison. I mean, they literally released last week, so I would not have enough time to prepare all the benchmark results for the newer version.
Okay, yep, fair enough. All right, here's another one for you. Have you run any benchmarks that include cross-partition? Oh wait, didn't I just? Yeah, I just asked that one. Here's a different one. Does Ignite support TLS/SSL/HTTPS?
To my knowledge, yes. You can configure TCP communication. So Ignite has uses TCP. May utilize TCP in 2 ways: for node discovery and for node communication. Generally, SSL becomes important for node communication, or TLS becomes important for node communication. And to my knowledge, Ignite does support SSL protocol. I would have to double check on documentation, but Ignite does. You can configure the communication to work over SSL.
Okay, great. Here's another one. First, I say hi there. First of all, thanks for this presentation. Seems that Hazelcast queues are really slow. There's an actual issue for this at Hazelcast's GitHub. Queues are quite important to us. How does Ignite's queues compare to Hazelcast's queues?
All right, that's actually a very good question. We're getting deep into feature set now. So as far as Hazelcast queues goes, so Hazelcast queues, as far as I know, are co-located queues. So essentially, all the elements of the queue will always result, which will always reside on the same node. So if you can have many queues, and they'll probably end up on multiple nodes, but the content of the single queue will always reside on one node. In Ignite, you can actually configure this. So Ignite queue can be either partitioned or collocated. So if you have a large queue that you want to populate within the cluster, the queue will be distributed within the cluster and work in a normal queue FIFO fashion. It actually implements blocking queue API from Java. So you utilizing the same API, or you can use collocated implementation as well, the same one as Hazelcast provides. So I would say the first answer would be that Ignite can support larger queue sizes than Hazelcast just because it can partition queue across the cluster. As far as performance go, I think we need to create a performance benchmark of Ignite queues versus Hazelcast queues and add them to the Yardstick comparison. But we have not heard complaints yet on we have a very active user list, and we have not heard complaints about performance of our queues. I believe our queues are very fast. We constantly run tests on them themselves. It just hasn't been, a Yardstick benchmark hasn't been created. But I'm getting all these questions here, and I'm already having a list of new benchmarks that I can add to the Yardstick so people can look at them. By the way, Yardstick benchmarks are not only to compare performance numbers, they actually can serve as a good set of examples on how to configure and how to use each product under significant load. So you can look at them that way as well.
Okay, yeah, and speaking of that you just said, here's another question, which is, do you have a comparison with Gemfire along the same lines?
We do not, and simply because Gemfire is a proprietary product, and the Gemfire license will not allow us to, or Yardstick, or us to actually start running comparison with Gemfire and publish it. So just from a license standpoint, we cannot compare to Gemfire. If it was an open source Apache project, we could, but since it's a closed source project, it has a custom proprietary license that will not let us do so.
Okay, great. Here's one. Is Ignite streaming done in strong consistency mode?
So the answer would be yes. So Ignite streaming is ability to ingest data into Ignite caches. The only difference is that we have a streamer API which does it very effectively. It does a lot of bulks and batch operations in between. But it's fault tolerant, and it will make sure that if any node, anything crashes in between, all the stream data will be rerouted to another node. But given that we're working with Ignite caches in a sliding window approach, in a sliding window mode of those caches, all the features on caches is, again, they are transferred onto streaming as well. So the answer is yes, since caches are strongly consistent, streams are also strongly consistent.
Okay, great. Here's another question that I like. If there's one feature that Hazelcast does better than Ignite, what is it?
All right, here we go. I think, if I would have to myself look at and compare again to projects and look at all the feature sets, there are different features. For example, the way Hazelcast supports services is different from the way Ignite supports services. I think maybe on data structure side, Ignite supports queues, sets, and a few other data structures. Hazelcast would probably have a couple of more data structures. It has a semaphore, and it also has multi-map. I don't believe Ignite has those. So that would be something that would that would draw my attention immediately. But there could be stuff that I'm not aware of.
Okay, just time for a couple more questions, maybe. So here's one: can you benchmark compute grid using the same approach?
So that's actually a very good question. Can you only benchmark data grids, or you can also benchmark compute grid in the same fashion? And the answer is yes. You can actually benchmark anything you like. It doesn't even have to be compute grid or data grid. Yardstick will execute any piece of code you provide it with on the cluster and will collect the metrics throughout the runtime of the benchmark. So you can benchmark streaming, you can benchmark compute, services, data grid, pretty much the whole feature set the whole feature set of Ignite or any other operations that are outside of data grid. For example, if you want to run any benchmarks that have nothing to do with data grid, you could create those and execute on top of Yardstick as well. It's a fairly cool framework that is entirely pluggable. So it allows to easily plug in your own benchmark.
Okay, good. And here's one more. I mean, there's more questions coming in, but let's do this one. How easy is it to now let's do this one. What are the main advantages of Yardstick versus other benchmarking frameworks?
Well, I mean, I've looked at several others. There's YSBI, probably I'm misspelling it. There are a couple others. The main advantage here is the Docker support of Yardstick, the convenience of running a benchmark just by providing a GitHub repository. And another one is graphs. You generate cool reports. You can see inside of the benchmark, you can collect a lot of data throughout the benchmark execution. So I think, I mean, I haven't seen any other framework that for benchmark that would come close to this kind of functionality.
Cool. Okay, I think we'll make this the last one here. So currently, we use Hazelcast to put streaming events in cache and use Drools, that's D-R-O-O-L-S, Fusion, to CEP. Can this be replaced by Ignite?
Well, I mean, given that both Ignite and Hazelcast are JCache compliant, so at a minimal level, the same standard is implemented in both products, so my answer would be yes. There are differences in querying. I would say that you probably will notice that you can do cross-cache queries and cross-cache transactions, cross-partition transactions in Ignite that probably not available in some other products. So I would say that my answer would be yes, give it a shot. If you run into problems or you run into any questions, please post them to our community forum. The link to the forum is directly available from Apache Ignite website. Generally, questions that you post to the forum get answered within probably a few hours. Okay,
great. Okay, I think that'll wrap it up for today as we're closing in on the end of our time. I want to thank you, Dmitry, for all that excellent information and also the audience for all those really great questions. And I'm sure everyone got a lot out of today's presentation. You can access a PDF of the presentation in the attachments area that I mentioned before up at the top of your screen, as well as a feature comparison document that compares the features of the GridGain in-memory data fabric with Hazelcast. So be sure to check that out. I would like to remind you and ask you again to rate the event and leave any comments or suggestions you might have that'll help us to improve it for next time. And finally, I did want to make sure that you were aware of the first ever in-memory computing summit. And Dmitry, if you could just advance to that slide so they can see the code there. This is the in-memory computing summit that's coming up June 29th and 30th in San Francisco. The event is sponsored by a lot of the leaders in the in-memory computing, like computing space, like SanDisk, MemSQL, DataTorrent, ScaleOut, SAP, TIBCO, and a lot of others, and of course GridGain. With some of the top experts in the field will be speaking. So, and there's still time to get some early bird discounts. So check out the discount code here on the screen, and you'll also see that discount code in the PDF of the presentation if you go download that from attachments. So with that, I think that'll do it for today. Thanks again for attending, and have a great rest of the day.
Thanks, everyone.